Hey y'all, welcome to Miss Clark's chemistry class. This is the second lesson on a series of lessons about oxidation and reduction reactions. In this lesson, we're going to talk about how do I know which part of the reaction is oxidation and which part of the reaction is reduction. Make sure and go get your periodic table, get something to write with, and let's get started. So let's start by looking at this very basic redox reaction. First, we got to make sure this is a redox reaction. And the only way to know if something is a redox reaction is to go through and assign all the oxidation numbers. So let's look at zinc. Zinc is a free element. It's all by itself. There's not a charge. So zinc is a 0. Let's look at copper. This is the ion copper, and it's telling us it has a +1. So that's what we're going to use. Zinc, the second zinc is telling us it's a +2. Yes, I realized it says 2+. I said +2. I interchange. It can be interchanged. It's not a big deal. And then that last copper is a free element. There is nothing with it. It's also a 0. So if we wanted to compare zincs, we had electron changes. If we want to compare coppers, again, we had electron changes. This is a redox reaction. But we need to decide which portion was oxidized and which portion was reduced. If we're looking at zinc, it went from a 0 to a 2. So to go from an oxidation number of 0 to 2, that means it lost 2 electrons. Remember, as the oxidation numbers get bigger, we're losing electrons because electrons are negative. It's going to feel a little bit backwards, and that's okay. And then if we look at copper, copper went from +1 to 0. Its oxidation number is getting smaller. That's because it's gaining more negative electrons. So copper gained 1 electron. So since zinc lost, now remember, we've got 2 mnemonic devices. Leo the lion goes grr, or we've got oil rig. Whichever one you like, loss goes with oxidize. So zinc, since it's losing 2 electrons, it is being oxidized. And copper is gaining electrons, it is being reduced. So when we look at those half reactions, we'll look at them as the oxidized portion and the reduced portion. So if we want to look at just the oxidized portion and we just said zinc was oxidized, we would just look at zinc, arrow, and then we want to show that it lost 2 electrons. Lost is going to go on the product side. Zinc was broken down into its ion, but we have to show those electrons. And then if we want to go and look at the reduced portion, the reduced half reaction, we would need to start with copper. Copper has that +1 ion, and then its product was copper. For copper to go from this ion to this free element, it had to gain an electron. So we show gain on the reactant side. So 1 electron plus the copper ion got us the free element copper. So you show loss as a product and you show gain as a reactant. Okay, so let's go through this example, and don't let this freak you out. There is more letters there, but let's go through and assign everything its oxidation number. This first hydrogen, it's an ion, and it's telling us it's +1. Okay, so let's move on to this next ion. I know that it's an ion because of this minus here. Don't let that skip out of your view. All oxygens are most of the time -2, so I'm going to put a -2 there. So if I've got this -2 and we've got 4 of them, that's like saying -8. But remember, the whole thing has to equal -1. So what must manganese be? That's right, +7. This iron is telling us it's a +2. This manganese is telling us it's a +2. Oops, I think this is supposed to be a plus right here. This iron is a +3. Oxygen, always a -2. And hydrogen in this case would have to be a +1 because we've got 2 +1s with a -2 that equals 0. Remember, compounds equal 0. Now let's go through and see what changed and what stayed the same, because I'm really only concerned with what changed. So let's look at hydrogen. Hydrogen is a +1 here. Hydrogen is a +1 here. We are not concerned with hydrogen. Let's look at manganese. Manganese is a 7 here and a 2 here. We are concerned with manganese. Okay, now let's look at oxygen. Oxygen is a -2 here. It's a -2 here. There was no change in oxygen. We're not really caring about oxygen. And then now let's look at iron. Iron was a +2 here, +3 here, we are concerned with iron. So we're concerned that manganese went from a +7 to a +2. We're also concerned that iron went from a +2 to a +3. Let's look and see what that means. Okay, so if manganese went from a +7 to a +2, it's gaining more electrons, right? If we're going from a +7, think about the number line. And if here is +7, and here is +2, and here is 0, and here is -1, for us to move from +7 to a +2, we're getting more negative. So here we have gained 5 electrons. And then if we're going from a +2 to a +3, we went in a positive direction. Positive direction means we're losing electrons, and we lost 1 electron. So manganese, since it's gaining, it's being reduced. Iron, since it's losing, it's being oxidized. So let's look at those half reactions. We just said that iron was being oxidized. So I'm going to go until I find my first iron, and I'm going to show the other half of that reaction. Again, that was supposed to be a plus right there, my bad. Okay, so that was the oxidized part, but we can't forget about that electron. Iron +2 broke down into iron +3. We can't forget that electron. And it lost 1 electron. Okay, so now let's do the reduced side. And remember, reduced was manganese. And even though oxygen was not involved, we have to include it in the compound. So we are going to write manganese with the oxygen. Now remember, that was a -1. And then the other half of its reaction was just the manganese with the 2+. We're not going to worry about this water because no portion of it was involved in being oxidized or reduced. Let's not forget this electron down here. Manganese. Now remember, manganese went from a +7 to a +2. So how many electrons did it have to gain? And there's those 5 electrons. Remember, we show loss as a product, gain as a reactant. Reduced R reactant, maybe that'll help, I don't know. Now let's talk about 2 more vocab words. We talked about oxidizing and reducing. Oxidizing is the loss of electrons, and reduction is the gain of electrons. But let's talk about an oxidizing agent and a reduction agent. A compound that contains the element being reduced is called the oxidizing agent. So the oxidizing agent contains the element being reduced. I know, weird, right? And then the exact opposite's true. The reducing agent contains the element being oxidized. Let me show you how to point that out. So if we go back to our reaction, we just said that manganese was reduced and iron was oxidized. So since in this process here, manganese, again, plus, manganese is being reduced. So this reactant would be considered the oxidizing agent. And since iron is being oxidized, this iron is losing an electron, the reactant portion would be considered the reduction agent or the reducing agent. So whatever's being oxidized, what it started from is called the reducing agent. Whatever is being reduced, whatever it started as, is its oxidation agent. Okay, so let's practice. This is everything that I would ask you about a problem. Everything. I know it's a lot, right? But don't worry about it. We're going to go through it step by step. First, we've got to make sure, is this a redox reaction? So let's go through and make sure that we've got some change of electrons happening. So let's look at this first magnesium. It's a free element. We're going to give it a 0. Oxygen, always that -2. Since compounds have to equal 0, if we're going to have this -2 here, and we have 2 of these things here, hydrogen has to be a +1, and hydrogen's almost always a +1 anyway. Do we see that? Make sure and leave me a comment if you don't see that. Okay, let's move on to magnesium oxide. Again, oxygen's always a 2. If these compounds are going to equal 0, magnesium also has to be a 2. Magnesium is in group 2, so it's always going to be a 2. Hydrogen, H2. This is a free element. It's diatomic, so that's okay that it's H2. There's no charge. free element. So if I'm looking at magnesium, magnesium went from a 0 to a 2, that's a change. Hydrogen went from a +1 to a 0, that's a change. So is this redox? Yes. Yes, it is. Okay, I'm going to use some room down here for my scratch work. So I've got magnesium, and it went from a 0 to a +2. And then I got hydrogen that went from a +1 to a 0. Okay, so let's go back and look at magnesium. To go from a 0 to a +2, our number's getting bigger. That means we lost 2 electrons. And for hydrogen, hydrogen's going from a +1 to a 0. That number is getting smaller because we're adding more negatives. So we gained 1 electron. Okay, so what's being reduced? Well, the thing that's gaining electrons, hydrogen, is being reduced. What's being oxidized? Well, the thing that lost electrons, that means magnesium. What is the oxidizing agent? Okay, so let's see what's being reduced. Hydrogen's being reduced. Okay, so here I see that hydrogen's being reduced. I go find hydrogen in the reactant. Hydrogen is a part of water. So what is the oxidizing agent? Water, H2O. Oxidizing agent, we look to see what was being reduced. Hydrogen is being reduced. We found it in the reactants. That is the oxidizing agent. Let's do the same thing for the reducing agent. Magnesium is being oxidized because it's lost, magnesium. We find it in the reactant. That's the reducing agent. It's just the opposite, right? Okay, so now let's do those half reactions. The oxidation is of magnesium, and then the reduction is hydrogen. Let me change color of pen so you can see where I'm doing, since I've already used that space. So the reduction half reaction is going to be what's with hydrogen. So we've got water, and then we broke that down into hydrogen. Not so much, right? It looks like a lot, but it's not. Let's do another example. This one looks a little bit more complicated, but let's go through and assign oxidation numbers first, because we have got to answer the question, is this a redox reaction? Let me get a brighter pen. Okay, copper, transition metal, we don't know. So let's jump into where we do know. Oxygen is a -2. Hydrogen is almost always a +1, and in this case, it works out. Now, hydroxide overall is a -1. So that works, a -2 + 1, but we do have 2 of those. So the minus side, the whole minus side, is a -2. So copper has to be a +2. If you're struggling with assigning oxidation numbers, you're not ready for this yet. Make sure you're good at assigning oxidation numbers before you go forward. Okay, let's go to NaCl. Na is a group 1, Cl is a group 17, fluorine's nowhere in the presence, so we got +1 - 1. That equals 0. That looks good. Okay, Na still a +1, oxygen still a -2, hydrogen still a +1. If we come over here, chlorine is a +1, but there's 2 of them. Oops, not a plus, minus. Chlorine is a -1, but there's 2 of them, so copper is a +2. Let's go through here and look. Copper +2, +2. Not what we're talking about. Oxygen, -2, -2. Again, not what we're talking about. Let's look at hydrogen. +1, +1. Not what we're talking about. Let's look at sodium. +1, +1. Not what we're talking about. And lastly, we've got chlorine, -1, -1. Not what we're talking about. There was no electron change here. Is this redox? No. And that's all we would need to do. Let's notice something about this reaction. This is a double replacement reaction that will cause a precipitate. Double replacement reactions hardly ever considered to be redox reactions. Hardly ever. Double replacement reactions, hardly ever. Okay, so let's look and see if this is redox. It's not double replacement, so that's looking pretty good. Aluminum, that's by itself, it's a 0. Okay, here is a compound, so we got to figure that out. So I'm going to jump with oxygen because I know it's a -2, but I have 3 of them, so that's like a -6. But I have 2 irons. There's our little algebra equation. What times 2 do we need so we can get that +6? That's right, we need a 3. Okay, so let's jump over here to aluminum and oxygen. Again, oxygen is a -2. We get that 6. There's 2 of them, so what must we need? Plus aluminum, it's always the 3, so that was helpful. And then this last iron, it's a free element. It's going to be 0. Is this redox reaction? Yes. Okay, so let's make our little notes. Aluminum, it went from 0 to +3. Iron went from +3 to 0. Oxygen went from -2 to -2. We don't care about oxygen. Okay, so aluminum went from a 0 to a +3. So that means we lost 3 electrons. Iron went from a +3 to a 0. So it gained 3 electrons. Gain is reduced. So iron is reduced. Aluminum is oxidized. Let's look at that half reaction. Okay, so the oxidation half reaction would be our 2 aluminums going to our Al2O3. But remember, we lost 3 electrons, and so we're going to show our electrons lost as a product. Our reduction, that's where we gained. So we're going to have Fe2O3 with those 3 electrons, and our product is just going to be iron. So if we're going to look at the oxidizing agent, let's see what's being reduced. Iron was reduced, so let's go and look at its reactant, and that is our oxidizing agent, Fe2O3. If we want to look to see what our reducing agent is, we see what was oxidized, go to its reactant, and we see that aluminum is the reducing agent. I do have one more example. If you've not tried one by yourself before I explain, then let's make sure you do that with this one. Push pause, work it out, check your answer. I'm just going to tell y'all real quick, I'm noticing that this is a double replacement reaction. And most of the time, double replacement reactions are not redox, but let's make sure. Okay, so sodium is a group 1, +1. Oxygen is -2, hydrogen's +1. We jump to this next compound. Again, I'm going to start with oxygen, and I've got hydrogen. So now we can just figure out this chlorine. I've got -8 because my oxygen's -2, and I got 4 of them. I got a +1. I need this to equal 0. So my chlorine is going to be what? That's right, +7. See, chlorine, normally a -1, but in this instance, not so much. Okay, so sodium +1, oxygen -2. We got the same scenario going again. We had a -8, +1. So chlorine again is a +7, -2, +1. I don't think this was a redox. Sodium 1, 1. Oxygen 2, 2, 2, 2. Hydrogen 1, 1. Chlorine 7, 7. Is this redox? No. See how important it was to know how to label those oxidation numbers correctly? If you can't do that, then you definitely can't figure out which part of the reaction is oxidation and which one is reduction. But guess what? We still need to learn how to balance these reactions. You know, they do not balance like regular chemical reactions. Make sure to meet me back for the 3rd lesson. Until then, bye y'all.